Hi everybody, this is continuation of lesson 2 and I'm just going to go through a couple of questions from page 11 in your booklets, which is on electromagnetic induction in a straight conductor. There's some questions on Lenz's law before that, but we will keep that for our next lesson. Okay, we don't want to do too much in one lesson. Okay, so the first one's quite straightforward. It says a wire which is 15 centimeters, which is 0.15 meters long, is moved at 2.7 meters per second through magnetic flux of density 3.1 Tesla. Now the direction of movement of the wire is perpendicular to the field. Now use V equals BVL to calculate the voltage induced across the ends of the wire. Now, one of the things you need to remember is that a voltage is induced, maximum voltage is induced when the direction of the magnetic field is at right angles to the direction of movement of the wire. And the direction of the current that's produced is again at right angles to these two. And that is why we used left-hand slap rule, because if you look at it, my thumb is actually at right angles to the fingers, and the fingers represent the magnetic field, and the palm of my hand, or the direction of movement, it's like the X, Y, and Z axis. That's again perpendicular to both these. Okay, now some people use rules like this. There are all sorts of rules for this, but this is what I use. Okay, so this one here, so the length of the wire, so that is your L is 0.15 meters, the speed is 2.7 meters per second, and your flux density is 3.1 Tesla. So you just use V equals BVL, just substitute, multiply all of them, and you get the answer to question 1. Question 2 is again quite straightforward. It talks about a car is moving with a uniform speed of 10 meters per second in a region in which the vertical component of the Earth's magnetic field is 5.4 times 10 to the power of negative 5 Tesla. The car's axles are metal rods, and they run between each pairs of wheels, and they give you the length of the axle. Now, question A says, why is a voltage induced across the axles of the car? The reason is the axles are made of a conducting material, and they are at right angles to the magnetic field. Now, you'll be able to calculate the size of the induced voltage using the formula. Now, I just want to go over question 3, which is about moving a length of wire between the poles of a horseshoe magnet, and they've given you the vertical height as well as the horizontal width of the poles of the magnet. I don't have a horseshoe magnet over here in my hand at home. We do have several of them in school, but I'll try and draw something here to help you understand what this question is and which of these lengths you have to use. Now, the L in the formula of V equals BVL actually stands for the length of the wire in the field. So the magnet, the poles of the magnet have got, that's the width, that's the height, and it kind of, gosh, goes like this, right? And then you have the opposite poles. You get the idea, okay? Not perfect. Okay, so I'm hopeless at drawing, but this is the width, and where am I? So they have a vertical height of 5 centimeters. So the vertical height is 5 centimeters, and the width is 9.5 centimeters. Okay. Now the wire, you actually hold the wire like this along the width. So it's this width of the wire that you need to use as the length of the wire in the field. And what you're actually doing with the wire is you're just moving it up and down in order to induce a voltage. So it says, which of these two lengths will you use? It's actually the width of it that you need to use. Okay. And I think you'll be able to answer the rest of it, because in the first video, I've kind of given you the answer to question 4. So I hope that made sense, and I hope you're able to do questions 1 to 4. This is for your first lesson this week, and bye for now.